Now let's jump through another few external crates because we're not going to, look at every external crate because there's, probably millions, hundreds of thousands maybe. And even in the playground, there's 100 or so. And so if you want to take a look at that, just go to the click on question mark here, and then go complete list of crates, and then you can get some idea of what sort of stuff is out there. So ANSI term, that's to I use this. It's for the terminal to give it colors. Anyhow is good for making result types. Let's see what else is there. Base64, I don't recognize. ByteMuck, I think, was to do with transmuting data safely. There's a function called transmute, which is unsafe, and they're working on making it safe. And I think that was part of it. Chrono is for time. The standard library does have functions for time, but Chrono has more. Let's see. Crossbeam is for parallel programming. It's like the MP multiple producer single consumer. Yeah, the MP-SC, except it's there's more function there. So Crossbeam is quite used quite a bit. Let's see, what else do we have? Error chain. Don't recognize any of these. Futures has to do with something we're not going to talk about. There are also smaller random crates. There's like fast rand. This is for hashing, other types of hash maps. Hyper, I think, was what was that? A web sort of thing. I think it's for making websites. I forget. Iter tools, you can guess what that is. Lazy static is quite popular. That's for like bringing in like big static pieces of static data that you don't want to call until later. So you can avoid having a big executable. I think that's what lazy static is about. I've never used it, but I see it quite a bit. What else do we have? Matches. Nope. Algebra. Algebra. Num is for lots of complicated math stuff. Num, of course, you see a lot because people use math a lot. I don't very much in my code, but num is you see it everywhere. Postgres is, of course, database. Proc macro. There's our friend Rand here. Rand core, blah blah blah, and also this is bringing in the ones that Rand needs. So there's one, Rand uses this thing called Rand Cha-Cha, and so it's brought in because it's needed for Rand, which is why this is more than 100. Serde, I'm going to look at that in a second. Serde is really popular. Tendril. This error is also another one to help you make error types. So this error and anyhow. So if you're making some error types and you're not enjoying it, then you can bring those in, and they will help you return like a general error type, and then Rust will be happy with all of it instead of having to pick the right error. Tokyo, this is for async. Not going to look at async, and I think there we go, we're at the end. So anyway, those are the crates that are used there, and one I wanted to show you is called rayon, and rayon is it makes a I like rayon because it's super easy. It makes if you're doing like iterators, then rayon lets you use multiple threads, and it's literally you have to type four more characters, and then it'll do all the work for you. So here's an example of that. So main function, let's say mute my vec, and we have this really big vec, and it's got 0 with 100,000 times, and then let's say we need to change everything. We want to change this 0 to the index number. So it should, up to 100,000, it should go 0, 1, 2, 3, 4, and then at the end it should be I think 999 or 99,999, because that's the index number. And so one way to do that is you call itermute, and I think my keyboard just changed. There we go. Itermute enumerate, and you remember enumerate gives you the index as well as the item, and then we're going to take that and do for each. Let's put this on different lines. There we go. Itermute dot enumerate for each, and enumerate of course gives you a tuple, so we're going to give it a name. We're going to call it index and number, because the first one is the index and the second one is the number, and we're going to say number plus equals index plus 1. That's right. So it'll go from 1 to 100,000. So it'll take that and make all the changes, and then to check if we did it right, let's see my vec, and let's let's print these indexes here, and see if we did it. And there you go. So it does. If we look at these indexes, we can see it's the right number that we wanted. And so this part here is what rayon can work with. So rayon can make this faster. And if you go to rayon right here, here it is. Rayon makes it drop dead simple to convert them into parallel ones. Usually all you do is you take this and then you add par, and par means parallel. So if we bring in rayon, so bring in the prelude right here. Use rayon prelude, everything in the prelude. And then all we have to do is change itermute to par itermute, and that's, let's see, use rayon prelude. And it should be spinning up some threads, and there you go. So you'll have to just believe me that this is faster. If you want to actually do some benchmarking, I've never done benchmarking, but there's something called cargo bench when you have cargo installed, and there's some external crates to do that as well. So yeah, that's all there is to it basically. And if you go to the rayon, the FAQ here, the FAQ, so it uses the same number of threads as the number of CPUs available by default, and all you have to do is add this par. So that is that's rayon. Serde is this one is for well, the name Serde comes from serialize and deserialize, and it's when you have a struct and you need to convert it to like JSON or something, or back from JSON into your struct. Everybody uses Serde because it's so good at that. So you do this, and all you have to do is this derive, and you derive serialize and then deserialize. So that's to convert it in and to bring it out, and then you just you can convert to JSON or whatever, and then you can convert it back. So Serde is there's a guy named Brian Cantrell, and he's the most entertaining restation to listen to, and he came from a C background, and he was always raving about Serde and how easy it made his life. So that's where I first learned about it. Although I've never found a use for it because I've never needed to put a database together. There's also regex crate, and there's chrono that I told you about, and that's all we're going to talk about here. Just a few of them. So go to crates.io if you want to, if you feel like exploring You just search here, and then when you find your crate, the place you want to go to get the familiar documentation is this docs, and then it'll even copy it for you. Like if you want to put this into your cargo.toml, you just do that and you copy, and then you paste it in, and you're ready to go. And even this here, this is a fairly new game engine, and it's getting quite a bit of attention right now, Bevy. And so if you want to start making a game with that, it's it's just as easy. You go to if you want to add it as a dependency, all you have to do is just write that in your cargo.toml, and then it will download all the crates you need to do it, and it's something like 150 or so. And Rust is compiling can take a while, but when you compile it once, then it becomes faster, and also they're always working at compilation speed. Are we fast yet? And if you go to this site here, you can it's called Are We Fast Yet? And this is where they benchmark all of the speed for Rust. Is this the right one? Are we fast yet? Rust. .rs. There we go. This is the right one. And so they are they benchmark the how long it takes to compile from these Rust versions here, and we're up to 1.50 now, I think. And you can see it's it's getting faster and faster. Hello World is getting slower, but most of them you see a lot of improvement, and also Bevy tries to be as lean as possible and make compilation faster. So anyway, that's what external crates are like, and as you can see, it's all about exploration and just poking through documents and having fun. And fortunately, if you have cargo installed, you can just add this to your cargo.toml, and you can get started, or you can of course fool around in the playground, and you don't have to install anything at all.